Stender, and you are at the talk about attacking web services. A little bit of defense there, but mostly attack. We're going to talk about who we are, what web services are, how they're being used. We're going to try to slam through this as fast as possible because we have a lot of technical stuff to get to. We're going to talk about some web service technologies, some that you might be familiar with, some that you might be less so. This is supposed to be a bit of an introduction to what security people and hackers need to know about web services technologies to understand their security. Then we're going to talk about some new attacks in those technologies, as well as some old attacks that have always been with us that are now twisted up a little bit to work in the web service world. And then there's going to be a demonstration. So please stay through to the end, even if you think I'm a boring speaker, because Scott has a pretty cool demonstration. He's going to attack a web service box that we've got out on the internet right now, and hopefully you guys can play along if you're able to get everything, all the tools running before the end of the talk. And then we'll be available for Q&A. We're going into the lunch period, so if you guys just want to come on up, or you can drop us an email anytime. So, who are we? We are two of the founding partners of ISEC Partners. We're a small security consulting shop and research firm. I'm not here to sell you any kind of XML firewall products, so you can put those checkbooks away. It's okay. Scott and I do all application security consulting and research. That's all we do, and this web service stuff actually comes out of a lot of our personal experiences and things we've done in the past. Why do you want to listen to this talk? As you're going to see, web services are deployed all around us. I guarantee that sometime today, your social security number is going to go over a SOAP message somewhere. And so, even if you don't work with them on a day-to-day basis, understanding the security threats here is going to be very, very important, especially going forward, because we're going to see this kind of web service technology absolutely everywhere. Anybody here run an operating system that updates itself? Right? Basically all of the commercial operating systems that do auto-update use a web service interface for doing that. That's the kind of stuff that just happens in the background if you watch your traffic during the day, and you'd be interested to find out. Like we said, most of this work is based upon real-life experiences, although a lot of these attacks haven't been seen in the wild yet because people aren't doing them. That's obviously going to change as the Black Hat community, not this Black Hat community, but the bad Black Hat community, starts to get knowledge of this kind of stuff. And there's a lot of interesting research opportunities. This is a wide open field. There are very few people in the security community working in it. All these standards, all this security stuff being written is being written by the guys who write the standards, not by security people. And so there's a lot of work here. And it's good. You can see in this talk and find out what we don't know, and then write a talk for yourself that you can give a Black Hat next year about those things that we've skipped over or missed. So these slides have been significantly updated. If you have web access right now, I recommend you go to isecpartners.com/blackhat.html. You can get the latest version of the slides, as well as links to all the tools. We will be doing the demo and hoping you guys can walk through it with us. The tools run on Python and require a couple of dependencies. All of that is listed on the website. Please go and start now. And I do recommend later getting a new copy of the slides. It's very different than the one in the book. If we knew we could have our 30 pages ripped out, we would have. At least to generate buzz. But so what is this talk? Hopefully you're not going to need any background in these relevant technologies. This is a talk meant for security people. If we're getting talking in front of web service people, we have to explain what SQL injection was. In this case, we'll explain how SOAP works. We're going to introduce some of the security risks involved. A lot of these issues and protocols are going to sound familiar to you. One of the reasons web services are out there is things like XML and HTTP that people have a lot of experience working with are some of the fundamental technologies that they build these very complex structures on. And so a lot of those issues that are now carrying over, even issues that have already been dealt with in the web application realm for the last 8 years are now part of the web services realm. A little prediction of ours is, next couple of years we're going to see some significant number of vulnerabilities related to web service interface, either in commercial shipped products or the application servers themselves. We know for a fact that there have been patches that have gone out for major application servers for unknown vulnerabilities from either security groups doing research and giving it secretly to the developers, or by the developers finding it out themselves. So the bugs are already out there. You just don't hear about them too much. This is not a talk about the WS security standards. All those standards have to do with things like encryption and authorization and signatures and all that fun stuff, which is great and important, but has nothing really to do about breaking into a web service. If you're looking to talk about XML encryption, which God help you if you want to see a talk that talks about how XML files are signed, then this is in the top 3. So what are web services? It's an overloaded term. It's mostly overloaded because it's one of those things you can throw out and get a couple $1 million of venture capital thrown at you. For our purposes, we're talking about web services are protocols that use XML as their base meta language to describe the communication. They provide computer-to-computer communication, and this is an important part and where a lot of the security issues come from. Web services are not meant to be consumed by a human being. They're meant to be served up by a computer and consumed by a computer on the other side. Now, there might, at the end, be some kind of visible content that the end user can see, but the actual consuming of the web service traffic itself is not meant for human beings. They use standard protocols. W3C, Oasis, and WSI are the big standards bearers in web services. They're the reason that we have all these acronyms. Any complaints can go to Tim Berners-Lee at W3C for having all these crazy, unbelievably obtuse acronyms like XML-XA, CML, stuff like that. And they're designed to be platform and transport independent. Although a lot of these have come from closed vendors like Microsoft, those standards have become open and are patent-free and such. Why are web services compelling? Like I said before, they're built on understood technologies, so it doesn't take a huge amount of learning to learn how to build these. And likewise, it doesn't take a huge amount of learning to learn how to hack web service interfaces. The adoption by large software vendors has been very, very quick. It's hard to go out and buy an enterprise piece of software that doesn't have SOAP somewhere in the marketing bullets. And web services have been described to a lot of people as a panacea for for fixing especially internal to enterprises communication issues, and we'll talk about that a little bit. The scary thing, which a lot of people love in web services, is a lot of that magic pixie dust, right? That magic pixie dust that we've seen before, things like how Ethernet magically works, and you can get an ARC will tell, you can use ARC to find out what IP address goes with the Mac, and you can use DHCP to get your IP address, and you can use Pixie even to boot over the operating system. All that works magically. It's that kind of magic pixie dust that's always insecure, right? If something happens by itself without a human being involved, it's generally, there's probably something wrong with it. And that magic pixie dust has been spread all over web service standards and web service frameworks. For example, here we have a little 10 or 12 line piece of code. If you open up Visual Studio.NET 2003 right now, and you put that code in, and you compile it, and you have already set up Visual Studio pointing against an IIS6 server, it's going to compile that C#, it's going to create an ASMX, it's going to create discovery files, it's going to drop all that stuff in IIS6, it's going to register it as an application, it's going to register it in the UDVI server on that box, all that stuff from 10 lines and clicking it. And every time this little piece of code gets communication from the network, it's going to go through not just the standard network layers of information and an IIS6, which we've all dealt with before, but things like an XML interpreter and a SOAP handler that handles SOAP headers and SOAP enveloping, and that does encoding standards and that looks up namespaces. There's tons of stuff that happens every time you call that hello world over the network. And so that's what's really scary, because people writing web services don't understand any of that stuff that happens. Just like we saw with web applications, the developers are coming at it from the development side. They get their How to Write Web Services in 30 Days book, and that tells them how to write it. And from our side, from the security side, we're looking from the network side up, and it's becoming very clear that there's not a lot of understanding by the people writing the software themselves about what's actually happening on the wire. So the one reason we see web services all over the place is the value to corporate management is really easy to understand. And here we just put together some corporate speak. But in reality, if you're a big corporation and you've got a mainframe from 1977 sitting in a basement somewhere, it's got all your important information on it, and all of your hackers with gray hairs in their ponytails have already retired after they made all that money from Y2K. It's really hard to extend your functionality when you have that kind of system. And so people do things like they go out to IBM, who makes all this money selling stuff to extend the mainframes they sold in the 70s, and they go to IBM and they buy IBM products and they put a big SOAP application server in front of the mainframe, and they expose all that mainframe functionality through SOAP calls. And so now that I have that thing in front of my mainframe, I can get cheap developers who write things in Java and C# and even things like VB, and get them to talk to my mainframe to be able to build big extensible applications. That is a real big value, and that's why people are spending a lot of money on this. It's also a little bit scary, because that's not what that mainframe was designed to do, and building that system so it communicates securely with the mainframe, and that the security protections that exist on the mainframe exist once you have a SOAP interface to access all the information, whether it's people's credit reports or people's health records. That's not that easy. So we're going to go through these real quick, so we've got to get to the important stuff. Where web services are being used between companies, the whole B2B thing, web services is kind of one of the original things that people were thinking about. If I want to work with a partner, such as I'm a credit card clearing company and I want to work with the bank, instead of using some kind of crazy binary credit card format like they've done in the past, perhaps I want to use web services because it's easier to develop and I can use off-the-shelf frameworks like .NET and WebSphere and such. And it makes it a lot cheaper. So we see a lot there. We see a lot of internal to companies. You want your PeopleSoft, talk to your SAP. That kind of stuff is going to happen on the web services. There's this kind of not invented here issue that's always existed with people supporting other people's protocols. Since web services are a third-party product, a lot of people are willing to support it to give interactivity. In front of legacy systems, we just talked about things like AS400s and mainframes. Between tiers of web applications, this is a very interesting issue. People are now accessing between the web server and the application server, or between the web application server and the database, using XML-like standards, things like XPath and XQuery instead of SQL. Those languages like XPath and XQuery are really cool and really powerful and have a lot of security bugs, and we'll talk about that. So this creates an entire class of injection attacks. I'll just put X star. As they create new standards that have an X in the front, there's probably an injection attack that comes with it. And then the way that most people in here have been exposed to web services is through AJAX, Asynchronous JavaScript and XML, which is a new standard to have really cool interactive web applications. Who has used Google Maps? Right? Isn't it cool? You can do all this stuff and it never hits reload, and you're able to asynchronously pull up stuff like it'll pop up boxes while you're scrolling the map. That's all because the JavaScript loaded into the browser, instead of the page getting reloaded every time from the application, the JavaScript comes in the browser and creates a thing called an XML HTTP object, which was introduced by Microsoft in MS XML ActiveX control, and is now simulated kind of like that in Firefox and Mozilla. Everything but Opera, I think, supports this kind of stuff. And it creates this object that allows it to asynchronously talk back to the server. It can send down XML request and get XML back, and it's in that XML that it's able to get stuff like the address data that you looked up, and it can do that without a page refresh. And so it's like you're downloading what used to be a big binary thick client, like the Keyhole software, to go look at satellite images. That whole client is now implemented in some kind of scripting language and running in your browser. And so there's two interfaces now. There's the HTTP interface by which you get the HTML for Google Maps, and then you get the JavaScript for Google Maps. And then there's a back-end web service that you're not exposed to, that your browser is talking to Google. We're not talking a huge amount about AJAX because, all their implementations are generally customized, and so it's hard to talk about security issues that exist across all of them. Plus, they often use they don't use real web service frameworks. They create their own XML file formats. They might not even use real XML, but there are definitely security issues in that. You also have APIs to add functionality. Who here uses like one of the eBay selling services? The services where they'll bid for you and stuff. Those guys use a web service. They use a SOAP port that's opened by eBay so that things can happen automatically. They don't have to do screen scraping and stuff. Amazon, financial institutions. Anybody here use Money or Quicken? When you hit your little update my accounts, it probably uses a protocol called OFX. OFX 2.0 is based on SOAP. So that's a web service call that goes out to your bank. And like I said, as a replacement for thick clients, we're starting to see enterprise vendors that ship stuff to your desktop. Instead of writing that, they can just write JavaScript client that talks XML in the back end, and then that works in everybody's browser, and you don't have to ship a Mac client and a Linux client and a Win32 client. You can just have the JavaScript client that runs in Mozilla, and it'll run on all platforms. So what does this mean? It means that code has broken free from a lot of people's control. A long time ago, a lot of people offered a lot of services on the internet, crazy things like RPC and stuff. People figured out that was bad, and now you look at the outside of any large corporation, you'll see HTTP, HTTPS, SMTP, and then maybe some firewall management ports that they forgot to close. And that's generally it for most big corporations, right? Yeah, I heard some laughs there. We see those firewall 1 ports out there all the time. But we're getting rid of that because one of the reasons web service has been invented is because it's able to all go over HTTP over 1 port, and you can get it past firewalls. That's one of the selling points of web services. It's a RPC language over 1 port. And so there's a new slogan for web services, which should move up. We poke holes in your firewall so you don't have to, right? You can provide all your enterprise functionality over 443, and then you can fire all your network engineers because you never have to change the firewalls again. Obviously, for security people, that sounds not like a good idea. So we're going to talk about some new types of web service technologies. Web services have multiple things at multiple layers. It's supposed to be everything agnostic. We're going to talk about the technologies that generally people use when they talk about web services and that people will be using most in the future. We're talking about 3 layers. XML, like the actual language and how it gets parsed. SOAP, which sits on top of XML, is the actual web service magic. And then discovery techniques. There are a number of ways you can discover web services that are built into it. So XML. Who here has ever worked with XML? Yeah. Everybody, most people have. It's actually, it's a very complicated thing. It looks really simple. When you get an XML doc, that's like a config doc or something you change. But they decided that they're going to write a language that can represent anything. Right? And that doesn't sound like a very easy thing to be able to represent every piece of data that the mass of humankind can come up with. And so, there's all kinds of weird little corner cases that create very, very complex corollaries to XML. Things like binary data, internationalization, which is done through Unicode 1.0. XML 1.1 will do Unicode 2.0. Representing meta characters, right? XML needs to be able to contain XML, right? Has anybody ever gone to a website that tells them how to write XML? And that XML comes down in an XHTML page? Obviously, there's got to be some way that they can represent XML in a way that doesn't get interpreted in the XML. Defining and validating schemas. What does this document mean? That's a kind of complicated thing. There's a lot of technologies around the layout of documents and making them configurable. And then that makes parsing very difficult. The result, there's a very large problem space here for security researchers to research. And there's been very little research in the security effects of XML. There's dozens and dozens of standards in what's called the XML family. Most of them are controlled by W3C. If it's got X in front of it, it probably has nothing to do with XML. Very few people understand most of these technologies. There's no person on the planet that understands all the aspects of all these technologies, which is a little bit different than when we talk about web applications, when things were actually pretty simple, right? HTML and DHTML and HTTP, at least from a communication standpoint, that's not that hard to understand most of the aspects of that. With the X standards, there's entire bookshelves at Barnes & Noble full of XML books. It's out of control. XML is based on some simple but very strict rules. We're not going to go over them. You guys can buy an XML book. It's important to know when you're attacking, as we'll talk about later, because generally when you attack a web service, you need to have real XML. If you have crappy XML, it'll get thrown away very, very quickly, and you'll never actually hit the application you're trying to attack. People have built fuzzers that do just pretty much random stuff to an XML endpoint. A lot of times when they're not creating real XML, they're just fuzzing the XML stack, which is great, but there's only 3 or 4 major ones that get used all the time, and they've been attacked pretty hard. What you want is XML that gets through that little XML parser and attacks the application that's saying, hey, give me the data that came off the network. And this is a simple example of my wife's car as a XML element. I think everybody's seen something like this. This is a full legal XML document. It's got a schema reference and a namespace. So I say the version up here, encoding, is obviously a very, very important security-wise. The default encoding for XML is UTF-8, which is, as everybody here knows, is bit compatible with ISO 8859, at least within the Latin character set. Lots of cool little encoding tricks that you can. Lots of cool little encoding tricks that have existed that people are exploring with web applications. Things like UTF, non-minimal encodings, things like changing character sets and hoping the application magically finds that character set somewhere. That kind of stuff is really, really possible with XML because with web applications, Unicode support was kind of shoehorned in, and so you often only have things supporting it when you specifically tell it, right? Like a SQL Server, when it gets data from IIS, you have to install the Japanese language pack for it to understand Japanese, right? But because Unicode's a base part of XML, most things that speak XML can do lots of stuff in Unicode. And so there's a much bigger problem space here for attacking using different kinds of encodings. And then I have darn, I keep on hitting the wrong button. So some other important things in here, like we have these things called namespaces. Namespaces are Namespaces are created so that you can have multiple XML documents that define different things, and they don't overlap with each other. So if I'm an application, I can load a bunch of XML documents, and they define different things. If like this doc defines a person's credit history, and this doc defines a music file, they use different namespaces, so if they both have something called, now I can't think of something that's the same between a credit report and a music file. But if there's some word that was used both in a credit report and sheet music, then those things would not overlap with each other because they're using different namespaces. Namespace attacks are kind of cool. And then we have our XML, which is well formed there. XML documents are defined by schemas. The old standard for using schemas are these things called DTDs, which are files that aren't actually XML, so it kind of was stupid to define XML using something, a totally different standard. The new standard is called XML schema documents, XSDs. They are actual XML. I'll show you an example. They're very, very complex. There's all kinds of stuff that you put into them. They can either be standard or custom. The standard ones are things that are put out by standards bodies to say something like, I want to represent mathematical formulas in XML. Here's the XML schema to define mathematical formulas. And if everybody uses this same schema to communicate mathematical formulas, in theory, I should be able to implement my product just having the schema and not knowing about what other products I'm working with. And I'll create that document and it can be read by them. In reality, that's not always true. But, we're getting there. And then they can be custom in situations like where you write your own web app that has its own format. Most web service applications either use a custom XSD or don't use a style sheet at all, right? It's not something that auto-generates. It's not part of that magic that auto-generates when you create a web service. And that's actually scary because XML schemas can be very, very good security tools. They define how elements are put together and the order they're in, how many there should be. And that makes a lot of attacks, like where you play around with doing putting elements in there, or denial of service attacks like we'll talk about, where you send very complex XML. It makes it impossible because, if we have something very simple like that car, and our schema says you can only have 5 elements in here, and this is their names, then you're not going to be able to do those kinds of attacks. You can also do, using a kind of regex-like language, you can say what kind of data is actually permissible. And so you can implement input filtering using XML schemas. Very rarely happens for security purposes. Sometimes people do it for debugging and stuff. But that's a good defense against lots of stuff we're talking about here. And this is an XML schema. Nothing really special here. Really sorry about this whole 2-monitor thing. This is what I get for using a Microsoft product in front of a bunch of hackers. Somebody owning me right now? Is that what's going on? That's not nice. XML schema, we're laying out what things can be in our description of a car. In this situation, we're only doing filtering on one element, and we're saying that it has to be a year, an integer number between 1904 and 2010. Obviously, because that's in there, it now makes it impossible to put something like a control character or something dangerous in there. So now that you have the basis, we're going to get to kind of the things that actually are vulnerable. There are 2 standard ways of parsing XML. If I'm writing software and I want it to be able to understand XML, I don't want to write my own XML parser. So there's 2 standard ways of doing the parsing that's also defined by W3C. First one's called SAX. It's something like Simple API for XML. It's a stateless, step-by-step stream parsing. And generally when people, it's kind of like, I see a node, now I want to go to the child. And the parser doesn't track, it knows where I am in the document, but doesn't keep any real state for me, and it just goes step by step through the document. It's lightweight, it's not very intelligent, it's pretty easy to use, and a lot of people use it for when they do XML blocks that are pretty small or not that complicated. But there is a vulnerability in it, and the vulnerability in it is that it has, if you haven't validated your XML schema, then and you're tracking, say, your own A lot of people, when they use SACs, and we'll talk about this in XML injection, they'll step through and they'll find information they want and then write it out to variables. Unless you're doing your own validation, which nobody is, after SACs does its actual parsing, you can have XML injection, which means that people can overwrite data that it's already read. Because it's stupid, right? It's a stupid step-by-step parser. The parser that people generally use for very complex things like actual enterprise applications is called DOM, Document Object Model. This is very complicated and powerful parsing. I send you an XML document. Your application says create a DOM for this, and it creates in memory this big data structure that represents the document and allows me to do lots of different cool, powerful things on it. The creation of that document model in memory is not an easy thing, and we'll talk about that opens up for attack, different type of attacks, denial of service attacks against the XML parser itself. What's always a bad idea is people writing their own parsers. A lot of people will say, oh, I can just search for something, I'll do a regex. Maybe they try to simulate SACs parsing using, you can probably do it in 10 lines of Perl, if you really know Perl, or at just one line, right? But that's a very bad idea, because there's lots of corner cases of the XML. Just don't do it, right? It's not a good idea. Use somebody else's. There's good open source ones out there. So an emerging attack class, XML injection. This happens when I'm able to pass an input that gets put into an XML string, and there's multiple ways this can happen. Say I'm writing to an application and it stores its data as XML, either as a flat file on a disk or actually as an XML database. And so, let's say I'm buying a car and I upload my car's name instead of Toyota that gets stored in an XML database. I upload XML tags. If they're not doing proper input filtering, those XML tags will get dropped right into the database of the XML document as tags themselves, right? There's no default escaping an XML, right? You don't go, here's my tag, and then I'm going to do a quote or something like that. If by default, people are just catting things together, which they probably are doing, then it's going to be tag, tag, like our example here, which is a user record, which that should be somebody's email address that a bad guy has put XML in instead of his email address when signing up for this website. In this situation, if you are using a SACs parser, what probably happened when somebody wrote how to interface it with a SACs parser is they initiate a bunch of variables, right? Like my unique ID is 0 or -1 maybe or something, and a bunch of empty strings. And then they use a SACs parser to go through step by step, and then they have a little if block, a switch block, that says, okay, if it's the unique ID, write in my unique ID variable. And if it's somebody's name, write in my name variable. And this might sound contrived to you guys, but we've actually seen this more than once in real applications that use SACs. In this case, it's going to step through, record what the unique ID is, record what the name is, go into the email tag, record the email. Our attacker, obviously this red stuff is the stuff that's controlled by the attacker through an input field. Our attacker is now going to close off that email tag and open up another unique ID tag, which is not illegal in XML. They have multiple tags in the same name underneath it. It's just something that this person wasn't assuming when they wrote their program. And so I'm going to go through, take that unique ID, drop it into the variable, and I've overwritten the unique ID of 1, 2, 3, 4, 5 0. And then do the email again. The point of this is if I'm using a SACs parser and stepping through and keeping state myself, keeping the loading up the variables as I walk through, my result is going to be unique ID equals 0. Anybody have any questions about that? That one's pretty simple. It's honestly, yeah. Right. Yeah, Eric pointed out that if your ID is 0, that means you're generally powerful, right? Which is why, SQL injection attacks that give you the first user in the table are very powerful because it's often an admin or a database administrator. Same thing here. We probably, write a little script to brute force that to find something that was really powerful. Any question on XML injection? It's fun and it's very simple. We don't see it a huge amount because most people aren't using SACs in real enterprise apps. You see it in cheaper things that do web service stuff. XPath injection, on the other hand, is something that you generally see against people that are using DOM parsers. XPath is what's supposed to be a kind of a simple language for me to reference a part of an XML document. So that I don't have to, every time I want to find something in XML, I don't have to do all this stepping through, like jump into this child, and jump into this child, and then jump into this child. That I can just have a way to write, I want to find all the children that meet this Boolean. this conditional and give me all those people, right? It's a standard language for doing that, and all of the standard XML DOM parsers, Microsoft's, IBM's, everybody supports at least XPath version 1. It's kind of a cross between directory browsing and regex when you actually see the language. So in our car example, if this isn't a full XML document, but say cars is our root node, these are different examples of XPath statements that will get me different things. If I just say car, it gives me all the children of the node. It will return a list of all of these different things. If I say /car, then I reference I want just the car element itself, a list of one item. If I do // that's kind of like searching. I want to search for everything. That's a car element in the entire document. If I do car // it's going to be all the colors that are underneath it. And then the important part is a conditional. I want to search for all the cars where it has a child element who's equal to blue. It has an attribute equal to blue. So if this was a big, long document of a bunch of cars, and I use this XPath statement, I would get a list of these nodes themselves at the top that have that are cars of blue color. Everybody understand it? Yeah, it's pretty simple. This is XPath 1. XPath 2 is like 400 pages document or something. It's ridiculous. Nobody understands that. So we'll do XPath 1 injection. So XPath is often used to access XML-enabled databases. And all these databases are XML enabled, and the last one is actually XML native. And its native format for storing this information is XML-like. So you can send an XPath query to any of these databases, and they will take their SQL table. You probably have to define like what table you're looking at, lay it out like it's an XML document, and take that XPath and give you the information. Which, as you saw, XPath is really powerful. It's actually much easier than like a SQL statement. So what's the problem? Like SQL, XPath has code and data right next to each other, separated by delimiter. And that delimiter is our old friend, the single quote that everybody's seen from SQL injection. Unlike SQL, XPath, there's really no way of securely using it. Right? We often attack web applications where they're using SQL on the back end, and we don't find any SQL injection. And we say, oh, you guys must be doing input filtering. Like, input filtering, what's that? Like, what's SQL injection? That's because they're using things like prepared statements or properly calling the stored procedures that SQL injection doesn't work, right? A lot of people get accidental SQL injection protection because they optimize their application to use a database in a very fast method. That's not true for XPath. There's no way of making an XPath call other than putting together a string and giving a string to whatever thing you're talking to, whether that's a database or if it's your MS XML object. And so if an attacker can control any input into an XPath and it's not filtered, they most likely can return either arbitrary parts of the file and access arbitrary parts of the file, or return any kind of data they want to whatever call it. So here's an example use of XPath. We've got a big XML document or database, looks like the same thing to our application, that has users, these user objects, and these user nodes have a bunch of different things under them, like what name, password, user ID, all this kind of stuff, right? Just like I put together a SQL table. So in this case, this is what our application is trying to do. It's getting an input from a SOAP call, or even in this situation from a web interface, and it's saying, give me all the users where their name is equal to Joe and their password is equal to let me in. Pretty basic. Can you get down? Or space or something? Okay. Okay. So our simple XPath injection attack, which is going to use this little canonical XPath thing, that this is going to become as famous as or1 equals 1 semicolon. This is how we want to break in a simple way out of our XPath. We use our single quote, we break out of that little Joe block, and then we're now in the conditional statement that exists between name and pass. And we say or1 equals 1, which is obviously, what's that called? It starts with an S, something that's always true. Come on, Julia, majors here. Okay, this is always true. Or quote equals double quote. So this little block may look a little odd. This exists because we know that after we say Joe, we don't have, it's not like SQL where we can put a semicolon in, a semicolon dash dash, and it will throw away the rest of the line. We have to somehow use the quote they've already put in to our advantage. And so in this situation, we create two empty strings and say if they're equal to each other. And so because of the ordering of how conditionals work, or, and, this doesn't mean or this and then and this. It means that even though this one might not be true, and this one might be true, this or is the operative one, and so this whole thing returns true, no matter what. So what this does, in reality, since it's probably a // it's returning a list of all of the users that meet true. So all of the users. So just like a quote, or 1 equals 1, semicolon //. Depending on how your applications work, this might actually work. It might only take the first list element because XPath always returns a list. So if I'm getting the first element anyway, it might work. It might not break stuff. If you want to get a little better at it, you're going to actually try to figure out a field that means something under that. And so I break out, I say, or user ID equals 1, or, and then I do my quote, quote, quote. It disappears, it takes rid of this and at the end, and it returns everybody that has that user ID. Obviously, this last one requires a little bit of knowledge about the internals of the application, but still, that does exist. So, like SQL injection, like I said, requires a little knowledge of the query. This is much easier if you get error messages back. Yes, sir. No, it will. Username or user ID or, because there's 3 ors, it will take any of them. 2 ors in there. I don't think so, because I tried that, it worked. So we can talk about, actually, I know it's not, and you'll see in the demo, that works. Yes, sir. As I said before, please raise your hand and shout out questions if you don't understand me or you got something interesting to ask. No? So like I said, like SQL injection requires, it's helpful to have some knowledge of how the query is being put together and what the XML document looks like that you're reading. It's much, much easier if you get error messages back, just like SQL injection. Fortunately, as you'll see today, the default in ASP.NET and some of the open source ones is to return a SOAP fault with all the information about how the XPath broke. So you'll see that actually is more common than you'll see. Is Amit Klein here? Amit Klein? No? He didn't come to Black Hat? Anyway, he wrote a great paper called Blind XPath Injection that he claims he has a tool that can get the entire XML document out by either you get 1 bit out of it as a covert channel by either logging in or not logging in, and that bit by bit you can get the entire XML document out. I'd love to have that tool, so if anybody here knows him, please go bug him and tell him to release it. Like I said, XPath 2 is much more complicated. XPath 1 was 20 pages long. XPath 2 is like a 200-page specification. Lots and lots of feature bloat. Probably a lot of things in there that will give us shortcuts to these kinds of attacks. Haven't really looked at it yet because I'm not that bored to read the XPath 2 book, which was like seriously that thick. But one thing it does have that looks really cool is that you can reference external documents. So I might be able to do things like load files off the hard drive if access control is not set properly, or perhaps even load an XML document that I provide on the web. And that would at least let me track, might even let me do nasty things to that XPath query. XQuery is a superset of XPath 2 that is a replacement for SQL doing this XML stuff. It is the future. It is the new standard by which databases are going to talk to web applications. I highly recommend that you learn about XQuery because a lot of people like it. It's going to be a tighter standard than SQL was, right? Because everybody's SQL is actually incompatible. They're trying not to do that with XQuery. And because it does have XPath in it, these same vulnerabilities will exist. And for example, if I was doing the same thing using XQuery, I'd ask a SQL database, if somebody supported XQuery, I think there's only a couple databases that do it right now. If I wanted to do the same thing, I would say from this document, which is the same as a table in SQL, I want to do this XPath query. And that same injection would work there, obviously. The downside for attackers, for us, the good thing for the world and the bad thing for the people in this room, is that access control is now going to be actually a standard because with XQuery, people are going to have databases that have good access control in different tables and rows. So the ability to walk willy-nilly through the XML document that exists right now pretty often is not going to exist there anymore. Yes, sir. It's almost never implemented. Does it? XML 3 or 4? 4? Okay. It's most things don't. So, Microsoft guys in the room, stand up. We'll give you applause. No? No? Okay. No, you're here. So in all of these attacks, we've got a friend in XML. It's called the CData field. CData is the way that was designed in XML to have, I've got a bunch of junk that I don't want to have to escape multiple times. And doing this, there are all different escaping methods by which you can do the same thing. This is the easiest way to do it. You create this thing called a CData field. And I'm not going to explain it too much, but basically it allows me to say, after this, don't think about the XML until you see square bracket, square bracket. And so I can put a bunch of crap in it and use it for injection. Right? It works for XML injection, SQL injection, XPath injection, cross-site scripting. If you're doing a cross-site scripting attack, it's a different web interface. Obviously, cross-site scripting doesn't do anything to a SOAP stack, but it will do it if somebody else is looking at this data in a browser. CData is really useful. The great thing about it is that it's invisible to the application developer, right? Although the information's in there, if I create a DOM of XML, it actually creates a CData child node. If I want somebody's username and I ask for the string and it was from a CData, that string just magically gets turned into my string, right? So it doesn't go through and do ampersand GTs or anything like that. So it's great if people aren't using XML schema to say no CData fields, then you're going to probably be able to do injection attacks using CData. So it's a great thing to try if you're having problems because you're doing XML injection or XPath injection and it's breaking the XML. Okay, any questions about those kinds of XML vulnerabilities and attacks? No. Okay, so SOAP is a standard that uses XML to basically do RPC, do remote procedure calls. It lets me use XML to say, hey, do something for me, and for that person to come back and say, yes, I did it, here's the data that you get from it. It's generally used over HTTP. And there's a standard specifically about how SOAP fits into HTTP, but it doesn't have to be. And it can be used over SMMQ or SMTP or the IP over carrier pigeon if that RFC ever gets implemented. So you can't really assume that's only over HTTP. This is where the magic begins of web services, right? The SOAP has a bunch of technologies wrapped around it that do all this kind of cool automatic stuff. And so because it's so easy to use in most of these frameworks, a lot of things are often left wide open. SOAP interfaces, right? If I'm a server, I provide a SOAP interface for you to call. That is defined by a thing called a WSDL, Web Service Description Language. It's this very complicated XML document. They're generally not made by humans. There are situations which humans do. Like, I think Google, when they make their APIs, they handwrite them because they're very simple and they want to have maximum compatibility. But generally, they're auto-generated by the frameworks. That little 10 lines of code I showed you before, if you hit compile in Visual Studio, the .NET framework will automatically provide you with a WSDL that describes that service if you ask for it nicely. We have a tool that asks for it nicely. And so they're actually really hard to read because they're not meant for human consumption. Being able to read it as an attacker is actually is useful. Because a WSDL gives you everything you need to attack an interface. And this is important because this is a big departure from web apps, right? A big part of attacking a web application is discovery of the attack surface. But if I have a SOAP interface and it publishes a WSDL, and I don't think they're playing any games with it, like it was hand-coded, if I think it's a real WSDL that was generated, that tells me everything I can do to that application. No more trying different, brute forcing different URLs, no more running Nikto to try all the different CGI bin directories. That WSDL just says, hey, here's all my interfaces, try to do something bad for me. These are all the things I can do. And so that actually makes writing really cool automated tools that are really, really difficult with web apps because that kind of discovery stuff is really hard. It makes it much easier in web services. And that makes it possible to write a kind of a universal fuzzer, which is something that we'll be talking about today. The question you need to ask yourself if you're on the defense side, do you need to provide somebody with WSDL, right? Are you opening up this web service for everybody to see? If so, then you might have to. But even in that case, are you opening it up for people that you don't know personally or that you're not going to talk to on a human level? Right? If I'm doing B2B, I can probably call the SOAP guy from the other company and email him a WSDL so that he can build his software to talk to my interface. That doesn't mean I have to provide it to everybody. The reason it's provided to everybody is because it's a default step and people don't know to turn it off. If you guys have web access right now, this URL's incorrect. Use the URL that was in that second or third slide that tells you where the service is, and then put !WSDL behind it, and you'll be able to see where WSDL looks like. Or you just go to wsdemo.itpartners.com and click through a couple of links, and it'll get you there. WSDLs define a bunch of things, like what types you can talk about, what a message looks like. A message might be, I want to buy a car. A port is a thing that is kind of a transaction that ties together multiple messages. Like I say, I want to buy a car, and then I get the message back, here's your receipt. Binding are the details of how web services are implemented. SOAP has multiple different document types, RPC, document literal. It's a total mess. Those kinds of things have to be defined in the binding. And then the service is where it's interesting. That tells you where that service actually exists, right? So if I have a WSDL file, I don't have to have a URL for a web app. So that's important, right? I don't have to know where that web service is because the WSDL tells me where it is. So this is why you can create big directories that all they have is WSDLs. They don't need to have any other information about the web services to provide people that, oh, these web services exist. This is an example of WSDL. As you can see, it's incredibly ugly and impossible to read at that distance. Even for something very simple, very large WSDLs get created. You can go ahead and look at WSDemo.isopartners.com. Go to the WSDL there. ASP.NET provides you a nice, pretty one. That'll give you a good example. So like I said, WSDLs give away all the sensitive information you need. Why does the up button not go up, but go down? Mic drop people? So WSDLs give away things like the hidden or debug methods that have always existed, right? Web apps always have some crazy little thing you can put into a post that do some kind of debug functionality. That kind of stuff used to be really hard to find by pen testers because you'd have to look really hard and you'd have to have source code, which is the nice cheating way, right? In this case, that kind of stuff would be automatically generated and pulled to you. We actually saw a real enterprise web application deployed on the internet that had a SOAP method called make me admin. Right? For debug uses, you can log in as my low rights user, and then I just call that interface, and I become the admin. I can do all kinds of stuff. That was their little backdoor. And putting make me admin in the right field in a post might not have been something I would have found anyway. But it's really easy if you're looking at a WSDL. This also not only in the application, but as people start to move over to using web services, these kind of CRUF systems that everybody has, who here knows of somebody's like FTP job in the middle of the night, right? All kinds of crazy things happen in real enterprises with billions of dollars moving around. That's like a 9-year-old FTP program moving a binary file across the internet unencrypted at 2 a.m., right? That kind of stuff, as it gets moved over to web services, is going to be advertised and visible. And so people are going to have to actually pay attention that they're doing this stuff securely. So the defense here, if you have to publish a WSDL, you go through and manually edit it, or you create your own by hand to get rid of the dangerous functions that you don't want to expose, if you have to expose those for debug purposes. The best thing is to get rid of that stupid debug functionality or anything that you don't want people to see, because very possibly your stuff will magic generate these WSDLs again anyway. So even if you edit it, you're kind of screwed in the end. So different types of attacks. SOAP has an envelope, which kind of says this is SOAP, these are our namespaces. It has a header, which generally isn't used by most things, but the header is very important because that's how they support all these crazy signature standards and stuff like that. And then the body. The body's got the that's important. The header doesn't even have to be in the message for the message to be understood, but it's still understood by web service frameworks. Whether or not your application says, I need to use something in the header, the web service framework will eat that header up. So what's this mean? It means you can put arbitrary XML complexity attacks in the header. And no matter if people are doing XSD schema validation, if they're doing like a SAX parser that's smart and stops after it hits something stupid, no matter what they're doing, if you send a SOAP message that has something nasty in the header, that's going to get parsed, and whatever happens in there is going to happen before the application even gets the data. It has nothing to do with the person's application. It has to do with the web service framework, the WebSphere or .NET or Apache Access. They eat the headers up. So one attack is XML complexity attack. We're going to talk about XMLs and POMs in a second in there. Another attack is using source routing. There's this thing called WS routing. People want to be able to provide, these XML firewalls do this, want to be able to provide multiple web services through one port 443 because it wasn't insecure enough, right? And so they use things like WS routing to say, hey, I want to talk to your mainframe, I want to talk to this. If you assume that stuff's just going to be figured out automatically by the software, you're probably wrong. There's source routing and WS routing, and it's still header. There's a thing called the SOAP action header, which is you can change it what the method style is, and you can sometimes bypass connections. Sorry, I'm going to have to whip through this now. SOAP is stateless, like HTTP. You do a port, you do something, you get the response back, and then you're done. Right? It doesn't have any state mechanism to track the user and stuff. That's left to you. A bunch of people, different people use different ways of tracking SOAP sessions. One common one is using HTTP cookies, which is pretty foolish because SOAP is generally you have one HTTP connection, the cookie comes across, and then who knows what happens to that SOAP message. And so we've seen situations where people have an HTTP cookie that goes with a SOAP message to my session information, and then that gets stripped and the message gets sent to an AS400 or something, and that message stands alone without any session information. Now obviously that opens you up to be able to basically do anything, right? You can also do in-band session, which is how most people do it, right? I'll do a login, and it will send me something back that says, here's your session ID, and then I'll just include that as a field in every request. That's not a bad way of doing it. Obviously, if you do that in a stupid way, like people always have with sequential, or, ooh, I'll count from 1 to 10 and do a SHA-1, and nobody will ever figure out that's a SHA-1 of a number that's incrementing. If you do stuff like that, you're going to get caught, and that stuff is still stupid. One benefit to using SOAP as opposed to just regular HTML is that it's actually hard. I can do my image equals name plus document.cookie. That's an XSS attack that will work on most web applications to get the cookie. That kind of stuff is actually really difficult. I have to interact with the XML object underneath it. So cross-site scripting attacks are much more difficult against like Ajax application to get that session information. So SOAP is also stateless, so it might make applications vulnerable to replay attacks. If I have a 3-step transaction to transfer money, I ask for the money transfer, then I confirm the money transfer, and then it says, yes, your money's transferred. Make sure that second step in your application, when you send up the information somebody needs to confirm, that it only happens once, right? Because people can replay that SOAP message over and over again and do the money transfer over and over again. So here's an example SOAP message. I bet Key Musaris is the first person to spot the attacker because she's closest to the slide. Right, this is a SOAP message that will be sent later today in the demo. Like I said, here's the little XML version that we always have in the XML doc. Here's the SOAP envelope. It's got a bunch of junk in there. It just basically says we're talking about SOAP in here. And then I have the body. And the body says I'm going to call a method, logon user, and I'm going to give it some arguments. This is the namespace, and this is the namespace of the user so that these variables belong to that namespace. And then here are my different arguments. My arguments are my username and my password. And in my username, I put a single quote. The password is default. So this is a little test to see if they're doing input filtering, right? Maybe they've got some XPath on the other side that takes this. And the result, as Scott will walk through later, this is the SOAP fault you get by default from ASP.NET. Server was unable to process request. Here is the XPath injection in why it broke. Thank you for coming. Please own me. That's what that said. There should be a flag in SOAP, a SOAP fault that says please own me. They should have a special code for that. Okay, so you guys will see that SOAP attack in a second, so I'm not going to go over it. So web service denial of service. This is a huge issue that nobody is really talking about yet. And I hope that people will start to after they see these attacks in a while. We personally have done this with a number of our clients. The way we did it is we created simple Perl scripts that are optimized for speed. And the great thing about these attacks is just like any DOS attack, I'm looking for a multiplier. You can get these great multipliers with web services. Even if it's just parsing of the message, the difficulty of me using Perl to open up an HTTP, to open up a sock and do an HTTP post of an XML document, that's a static document that I don't have to edit or anything, the difficulty of that versus what it takes the other person to take that document, and now I'm going to parse it, and I load it into my DOM. And my DOM builds a huge object in memory that represents this document. Oh, your document has 100,000 nested A statements. That's fine. I'll build an object that has 100,000 child nodes, right? Each one of those objects is a C# object running in the CLR with its own garbage collection. And you can imagine this can get out of control. There's a huge multiplier there. There's CPU time, right? The CPU time it takes to generate those. There's memory space. Although you're probably not going to run out of memory space on a production server, certainly application servers have memory limits for different functions they provide. And so you might be able to run out of the memory of that and cause it to die. And those are XML complexity attacks, and we've done them and it works. Against production hardware with real-life current versions, you can send very, very complex XML documents on a laptop and take down a production for-proc machine with like 8 gigs of RAM. With one of these laptops, it's a ThinkPad T42 1.8 gigahertz. So because you get a huge, huge CPU and memory multiplier time, really the only restriction you have is network speed. And so if we were doing this in a lab, so we had like a 100 megabit switch, we'd have to do it distributed really on the internet to have enough, to use up enough bandwidth to send that many XML files. But it does work. Another thing that I can use up is database connections. So if I send a SOAP request that actually does something, that's a method that actually does something important, then it probably has to go talk to something about that. It has to go talk to a database, or an XML database, or a mainframe, right? And those things are generally defined by having pools. And so if I can find the thing that takes very little for me to do, but it takes you a lot of time to go to that database, I can probably use up that connection pool. Even if it doesn't overload the CPU and stuff, if you do it over and over and over again, you can use up that pool and make the application. We've done this too, and the application was not responding to user input, and it had like 4% CPU load, right? Because it had a reasonably sized database connection queue, like a 500 or something like that, which they had never run into in production use with millions of users. But in our situation, it worked great because we were doing something that we knew would take a lot of time for the database. We'd have to search through a huge table. And so if you can guess something, and how do I guess something? Well, I go to the WSDL and I look at all the things that look dangerous, like search for something, right? Or a user login. That's the perfect example. When I give you my username, you have to look through a huge table of users to find that username first. And if I know you have 100,000 users, that database is, that's going to take a significant amount. So in either case, there's a lot of details that you have to get right. You have to have a legal SOAP request, like we said. You might have to valid session ID. So in our script, we needed one, so we get a session ID, put it into the XML document, and replay it with the same session ID over and over again. That's why you want to have rate limiting on what one person can do. And then speed. Actually doing this kind of attack is much heavier than like a SYN flood, right? Because I have to get a real HTTP connection. I have to send it. I might have to listen for a response. Sometimes if you tear down the TCP connection, it will stop responding. But there are ways to do it faster, and one of them is HTTP 1.1 pipelining. This is especially important in an SSL situation where I don't want to do an RSA handshake for every single XML document I send up. So I create an SSL connection, I create an HTTP 1.1 pipeline, and I send it up over and over again, and I just create 20 or 30 or 40 of those connections, and that will be it. The server's gone. Defense isn't easy. This is something the application server people have to take care of because, you guys can protect yourselves. You can use XSDs and such, but there's nothing you can do about the SOAP header, right? That's eaten up by .NET. That's eaten up by WebSphere. That's eaten up by Apache Access before your application gets called. And so you need to check the complexity of the document before it gets in. One thing they put in here, good protection, is just to have reasonable limits on your web server of what people can post. Right? There's no reason somebody needs to post up a 10 meg XML file if that's never part of it. Most people's SOAP requests and responses are 50K. So if you say 100K and you double it for safety, that's going to greatly affect the ability of people to do really complex attacks. This is also why the XML firewall people actually sell some of their boxes. This is one attack that they do protect against. Discovery methods. UDDI is a method. It's not based on SOAP or any web service. It's XML. It's a way of advertising. If I'm a company, I have all these standards. I have all these services. So if I'm, let's say, the Bank of China, as we'll see next, and I say, here's my service for you to trade, to do your banking information. Here's our service for our commercial banking. I publish that through a UDDI server. We've seen these out in the wild. We've seen these for real on the internet. And people are like, oh, we haven't told anybody about it, so we'll never find all our secret B2B services, even though they have an unauthenticated UDDI server out there. There's these great things called the UDDI Business Registry. So everybody right now, if you have a website and you have a Hotmail, like a Passport account, go to uddi.microsoft.com. They all require you to register, but all you need is an email address to register, so I'm sure that'll keep the bad guys away, right? But Microsoft's easiest if you have a Passport. Passport will work. uddi.microsoft.com. That's a UDDI business registry. There's 4 major ones. They have these great web interfaces that let you search for things like, I want to find all of the banks that have an advertisement for you. One of the really scary things here is there's no real secure binding of who those people are. They're coming out with all these PKI standards for web services. They're not really being run yet, so it's difficult to know that Bank of America really is Bank of America. Actually, I could become Bank of America and post a Bank of America in the Microsoft UDDI, and nobody calls me to chat. That's true for all the UBRs. And here's the example. This is the Bank of China advertising their banking web service. Maybe it's them, I don't know. Could be anybody. But this is a nice little graphical interface. It's really cool. These things exist because of this whole buzzword called service-oriented architecture, which is the idea that computers can go out, understand that I need to buy stuff, and that computer can go find the person they want to buy from, and that person's actually another computer, and then do the purchase and all that happens automatically. It's kind of delayed binding of applications. It's a crazy idea. It's never going to work. It's going to be insecure. Watch out. There's other great third-party registries. Ecomethods.net has all these really cool web services like lookup census data and stuff like that, which is really neat. And then Disco WS Inspection is a lightweight version of UDI. It's a Microsoft standard that's becoming, WS Inspection is becoming just basically flat files that you put in specific parts of your web root that say, these are the web services I have. And our tool will find those automatically for you. And then we talk about our traditional application attacks. These all exist. SQL injection still exists, obviously. Right? If you have SQL on the back end of a web service, I can use my CData field, do SQL injection, wham, bam, thank you, ma'am. Same old, same old. Everybody's talking about SQL injection. Overflows and unmanaged code, right? All these web service frameworks, most of them are like Python or Java or C#, things that don't have overflows in them. But there are specific technologies meant to take C++ compiled code and wrap web services around them. And a great one's called .NET Remoting. Take a COM object, like just an off-the-shelf COM object, like an ActiveX object. You tweak it a little bit to make it have the right interfaces, and then you click a couple buttons in Visual Studio, and all of a sudden people can come over the internet, talk to your IIS server, and that IIS server will hand that information over to the COM component. Sounds like a great idea, right? And we know people are actually using it in the world because they've written these COM components that do dangerous stuff, like transfer money or buy stocks, and they don't want to rewrite them in C#, so we'll just wrap this stuff around it, and magically the information will get there. Obviously, if there's an overflow there, the overflow is still there. In the COM component, it's now just exposed to report 80. And then cross-site scripting still exists, like I said, either in Ajax applications that get XML information and then make it HTML displayed, like I get my Google Map information, it turns into HTML, or if I'm attacking it, somebody else's web interface. So we have two attack tools. We're going to demo one of them, Whizbang. The other one's called Whizmap. Whizbang is a fuzzer that does all its fuzzing stuff automatically. The other one's called Whizmap. Whizmap specifically requires you to use WebScarab to use it. We love WebScarab. We use it a lot. And it's great for a situation like if you're, it will take your WebScarab logs and it'll look at all the URLs you looked at and all the implied directories. It'll look for any web services and all that. So you spend a day doing your pen testing, you create your WebScarab logs, you run Whizmap, and then it'll give you a list of any web service interfaces that you may have run over. So it's really good for like debugging if you're using things like a thick client that uses web services and you can get it go through a proxy, that works great. And I'll let Scott explain how Whizbang works. So this is our attack tree. I think everybody understands how that works. So a big question, is the OS Top 10 still relevant? A lot of people here will say it was never relevant. But these are some good bugs. Every single one of these things still exists in web services. Some are a little changed, like cross-site scripting or buffer overflows, but they still do exist. And so our conclusion is that web services are powerful, they're easy to use, they're open, and they're extraordinarily dangerous because people are exposing real functionality, real health records, real financial institutions, real bank accounts, real credit reports are being exposed over web services right now, and the security research hasn't gone in, right? And this is just like we just need a little look at all these services. And a lot of these things are kind of the things like, you're like, oh my God, wow, maybe publishing UDDI by default to everybody isn't a smart thing. That's not the thinking in the whole web service community. Everything is open and should automatically work. Security is not a priority. And so it's up to us to go out there and do the research and build these tools and find the bugs and do it publicly so that these people go and they fix these standards so that they're secure from the outset. Right? It's a little scary that first we had web services, and now we have web services security. We'll write that 5 years from now, right? That's the thinking so far. And then this is our shameless plug site. We're hiring. Anybody wants a job, not working for corporate Google. They're welcome to drop us a resume to careers@exitpartners.com. And our partner, Himanshu Dwivedi, who's up here, why don't you wait for Himanshu, is giving a fantastic talk at 3:15. Own up an EMC. Do it. It's fun. Or buy the book. So we're going to do the demonstration. Do we have any other questions on the slide content that are kind of fast before the demo? Okay. Turn it over to Scott. You're going to see him actually hack a website.
Don't leave, it's really cool.
All right, can everybody hear me? All right. So, time for the demo. I'm the demo flunky. Here's the slide flunky. I wasn't very good at the slide flunky, if you saw.
third. Yeah, just click at the bottom of the third.
That's all. There we go. Okay, so at this point, I'm going to demonstrate Whizbang. Whizbang is a WSDL-based SOAP fuzzer. So what we've done, prior to this, is use WizMap to identify target web services, find their URLs, and then we feed that URL into Whizbang. So right here, we have a service that we found with WizMap. This is a standard ASP.NET web service. You'll see the ASMX extension signifying that. If you just add a little question mark to WSDL towards the end, we find the WSDL. So this is the default functionality of ASP.NET. Like you said, you do that 5-line web service, you hit compile, this is created automatically for you. By the way, this demo, I'm doing it off my local machine, but the same exact web service is out on wsdemo.isacpartners.com. You can work along. I just didn't want to mess with the network. So, there's our WSDL. When we open up Whizbang, if you recall from the command line, you just specify the full URL to the WSDL on the command line there. I just put hard code into the code right now. As you can see, this is written in Python. We released it under the GPL. It's also available at isacpartners.com. So, to run it, we simply run this, very simple, and we get back a very pretty HTML file, which contains the very basic output from the fuzzer. So in the first column, we see logon user. That was the name of the method that we showed earlier in the slides. We have the response. So this is the actual SOAP response. So when I go out and call the method, I get a string back. I print that unless I get an exception, in which case I print out SOAP fault. And we can see we have a couple of those in here. Then there's also a link to verbose information. So if we click there, we see the outgoing HTTP headers, the outgoing SOAP request, the incoming HTTP headers, and the incoming SOAP request. So if we look here, I don't know if you guys can see my cursor very well. I'll go point. So here we have the method name, logon user, and we have two parameters, username and password. And from the slides earlier, you can see that the username we specified is an apostrophe, and the password is just default. And that generated SOAP fault. If you look down at the bottom, you've already seen this. Server is unable to process request, and ASP.NET is nice enough to return the XPath query string to us. And we see login equals apostrophe, apostrophe, apostrophe. So that apostrophe just went right in there. There's no validation. There's no escaping. It's in there, and it is completely injectable. So we know we have a bug. Now, WizMap has a not quite Hollywood interface yet. There's no 3D rendered purling cubes or anything like that. But what we do have is a very nice object model, and when we run it in the IDE like this, you still have all the objects active. So what you can do is say fuzzer.invoke method. And for those of you who know Python, this will make a little bit more sense. So we have two, can you guys see that? Hopefully. Okay, so we have two methods of invoke method. One is the method name, and the other one is a dictionary that contains the named parameters. So remember from the SOAP request we saw earlier, we have username, and we're just going to say root for now. We want to go for the gold. Password, we don't know the password, so we're just going to put blah in there. We run that, we get a SOAP response back, and if you look here, it says username or password is incorrect. Well, what do you know? It wasn't blah. But we did see. Unfortunately, I can't adjust the font size in the console inside the but for those of you up front, you can see an XPath injection in Word. And so what we do is we finish off the quote. So what we see is login equals root quote, or apostrophe apostrophe equals apostrophe. So the full query string will be login equals root, or apostrophe apostrophe equals apostrophe apostrophe, or true, and password equals blah. Who cares? We just got an or true in there. We run that, and you will see successfully logged in user ID 0 name root. So we were able to log in as root without the password in this contrived example. What we saw in the back end there was, or if you were to look at the XML file where all these users are pulled out, you just saw 4 users, username, is root, user 2 was Alex Demos or something like that. Again, this is all up there on the wsdemos.isecpartners.com, and you can play around with it if you like. So the tool itself is pretty simple. Most of the stuff is in 2 classes here, fuzzer.py, or 2 modules here, fuzzer.py and dataprovider.py. You can use those classes for your own scripting, or you can just use the basic wrapper I provide in wsbang.py. Some of the features are that there's this datadeck.xml that allows you to fuzz parameters based on their type. So I can say, go through, find the WSDL, find all the methods, fuzz all the methods. Within those methods, you're going to have all the arguments, and those arguments are named types, thanks to the WSDL. So I can say, for every string, and you'll see in here, one of these definition names equals string. There we go. So with Bang, we'll go through, find the method, find that has a string type argument, and it'll say, okay, for every string, do everything that I've listed in simple string and XPath string. And so if you go look at those, you'll see that there's 1,000 A's in simple string and 1 A, and let's see what else we have in there. In XPath string, we have just quote and apostrophe. You can add all that you want. You can do repetitions. You can do references. And you can also say for default arguments, which we didn't use in this example, but if you say, let's say we have a web service, we have to get a cookie, and then pass that cookie as an argument with every other request to the services. You can say, okay, for everything that's called cookie, give my cookie that I got, 1, 2, 3, 4, 5, and then fuzz everything else. This will allow you to do that. And that is a quick demo of the tool. Does anybody have any questions?
So he was